Edible birdnest or EBN is a traditional Chinese cuisine that has gained attention not only locally but also worldwide. It is produced from the saliva of swiftlets, which hardens to form a nest structure. Nutritionally, EBN is rich in carbohydrate, proteins, and amino acid, making it a valuable food from a nutritional and scientific perspective. Today, actually, EBN is no longer limited to a traditional food consumption. It is increasingly used as an ingredient in cosmetic and pharmaceutical product because of its potential health benefits such as antioxidant and skin supporting properties. In terms of source, EBN is actually rich in a mucin like glycoprotein, which form most of the nest structure. However, glycoprotein are also found in other food such as egg and milk, where they play important roles in nutrition and immune function. Other sources include fungi like mushroom, plant-based foods such as rice bran and honey, and marine sources like a sea cucumber. From a food chemistry perspective, EBN is actually important due to its protein content, particularly glycoprotein that contribute to bioactivity. It also contains bioactive compounds such as salicylic acid and peptide, which may exhibit antioxidant and immunotherapeutic effect. Additionally, its physiochemical properties, including amino acid profile and nutritional characteristics, influence the food quality and product quality. For this slide, I will explain what a glycoprotein it is, followed by the biological function and the physicochemical properties, particular in edible bird nest. A glycoprotein is a type of protein molecule that has a carbohydrate attached to it. This attachment occurs through a process called glycosylation, which can happen during the protein translation or after the protein has already been formed as a post-translational modification. The presence of carbohydrate chains change the structure and function of the protein, making glycoprotein important in many biological and food-related processes. Now, let's moving on. In terms of the biological function, glycoprotein actually in edible bird nest may exhibit antioxidant activity, which helps protein cells from oxidative stress. They also play a role in immune modulation by supporting immune system function in addition. In addition, glycoprotein may have antimicrobial effect, helping the body defend against the pathogens. Another important function is cell growth, stimulate, and tissue repair, which is linked to growth factors in bioactive peptides released from glycoprotein. From the physicochemical perspective, edible bird nest has high protein and glycoprotein content, making up about 50 to 65% of its dry weight, depending on original and processing method. It is also rich in salicylic acid, which is a key component of carbohydrate, influencing biological activity and physical stability. Furthermore, glycoprotein contribute to functional properties such as dilation, emulsification, and solubility, which can change with. Now let's moving on to the structure of glycoprotein and edible bird nest. So as we seen in the picture, glycoproteins in edible bird nest consist of a protein backbone with carbohydrate chain attached. The protein part is made up of amino acids such as serine, threonine, aspartic acid, glutamic acid, proline, and valine. The carbohydrate parts include such as sugar like salicylic acid, galactose, and glucosamine. The sugar chains are covalently attached to a protein through the glycosidic bond, mainly owing to serine or the threonine. This combination form mucin-like glycoprotein structure, which give edible bird nest its gel-like structure and bioactive properties, such as antioxidant. The structure influences EBN solubility, stability, and biological activity. There is a reason why EBN can act as emulsification.
Next, I will discuss about the source of edible birdness and main component. Edible birdness is produced from saliva or succeeding bird during nest construction. When the bird strikes the saliva, it's gathering hard upon exposure to air and form the nest structure. Each nest is very unique because it is rich in water-soluble bioactivity component, which is contribute to the nutritional value of edible birdness. These components are important. They are responsible of many of biological activity related with edible birdness. Edible birdness contain various water-soluble bioactivity components, and the one of major component is glycoprotein. Glycoprotein are protein that link with carbohydrate chain. As you can see in diagram, this glycoprotein play important role in inhibiting to antioxidant activity and supporting cellular healthy. Because of this benefit property, edible birdness are strong potential to develop as a function food and nutritional product.
First, the main active component of bird's nest glycoprotein, and its amino acid composition is dominated by polar amino acid. The common amino acids include serine, threonine, aspartic, and glutamic. In addition, bird's nest glycoprotein also contains a certain proportion of non-polar amino acids such as leucine and valine. And the polar amino acids plays a central role in bird's nest glycoprotein. Polar amino acids such as serine, threonine, aspartic, and glutamic can form hydrogen bonds with water molecules, thereby significantly improving the water solubility, water retention, and viscosity of glycoprotein. In construct, non-polar amino acids such as leucine and valine are mainly involved in the protein bonding process through the hydrophobic interactions, forming an intertial hydrophobic core, which helps maintain the spatial conformation and the structural stability of glycoprotein. And then the relationship between amino acids composition and the biologic functions. First, the glycoprotein is rich in polar amino acids, making the overall structure highly hydrophilic, which directly determines its good solubility, lubricity, and moisturizing properties. At the same time, the synergistic interactions between polar amino acids and glycans, which in glycoprotein structure facilitates interactions between molecules and the cell surface receptors, which can closely related to cell repair, immunoregulation, and tissue regeneration. Although bird's nest glycoprotein is not a rich source of essential amino acids, its unique amino acid compositions and glycosylation structure confer high function value and biocompatibility, making it highly significant in nutritional science and functional food research.
Now I will proceed with glycoprotein structure. What is definition of glycoprotein? A glycoprotein is a protein that contains one or more carbohydrate chains that are covalently attached to its amino acid chains. This attachment process is known as glycosylation. In this example, edible bird nest is rich in glycoproteins. These glycoproteins play an important role in providing structural stability, biological activity, and functional properties. As shown in the diagram, the glycoprotein consists of a polypeptide backbone with glycan chains attached, including sugars such as sialic acid, which is important for biological function. The next slide is about protein backbone and carbohydrate chains. First, the protein backbone. Protein backbone is composed of amino acids linked together by peptide bonds. The structure is stabilized by hydrogen bonds, hydrophobic interaction, and disulfide bonds.
The protein backbone can release bioactive peptides that have antioxidant, antihypertensive, and anti-inflammatory activities. Next is the carbohydrate chains. These carbohydrate chains are covalently attached to the protein through glycosylation. Most of them are N-linked glycan. They are mainly composed of salicylic acid, galactose, and acetylglucosamine. These carbohydrate chains help regulate water binding capacity, biological activity, and the functional characteristics of edible bird nest.
Good day, everyone. My name is Chia Hui Ying, matrix number A209351. Now I will continue to the part of bond and conformation of edible bird's nest. The unique nutritional and physical properties of edible bird's nest are defined by the specific chemical bonds and molecular conformation of the glycoproteins contained in the edible bird's nest. In this part, we will talk about primary chemical bonds, structural conformation, and conformational changes during processing. Now, let's move on to the first part, primary chemical bonds. The fundamental structure of edible bird's nest is held together by two types of covalent bonds that link amino acids and sugar molecules. The bonds that I would discuss is peptide bonds and glycosidic bonds. Firstly, let's take a look on the peptide bonds. Amino acids are linked via the peptide bonds to form the primary polypeptide backbone of the EBN. The polypeptide backbone of the EBN consists of parent proteins such as acidic mammalian chitinase-like and ovoinhibitor-like proteins. Heat or enzymatic treatment, such as using the protease, could break the bonds, releasing the smaller bioactive peptides that are more soluble and easier to absorb by the human body. Next, I will talk about the glycosidic bonds. Edible bird's nest is highly glycosylated, meaning that the sugar chains are chemically attached to the protein backbone, where these sugars are linked to each other and to protein via the glycosidic bonds. It also contains both nitrogen-linked and oxygen-linked glycosyl proteins. Salicylic acid, which also known as N-acetylnuraminic acid, is often found at the terminal ends of the chains via alpha-2,3 and alpha-2,6 linkage. Now I will continue with the structural conformation part. In this part, I will mainly discuss about the secondary structure and tertiary structure. In secondary structure, we found that edible bird's nest involves the folding pattern, which also known as beta sheets. The analysis via FTIR spectroscopy, which is Fourier transform infrared spectroscopy, had revealed a high prevalence of beta sheets and beta turns. This had contributes to the characteristic of the EBN, which is tight pack of the protein strands, water insolubility, and stony texture of the raw nest. Next, I will talk about the tertiary structure. The tertiary structure related to the overall three-dimensional shape and stability of the edible bird's nest matrix that is maintained by the two key interactions that will be discussed later, such as disulfide bonds and hydrogen bonds. In disulfide bonds, the cysteine residues form a strong covalent disulfide bridges, which act as the molecular staples cross-linking the different protein strains into the high molecular weight of aggregates. Next, I will talk about the hydrogen bonds. The bonds between the polar groups contribute to the stability against the heat. Hence, during the cooking or heat treatment, the heat will disrupt the hydrogen bonds, allowing the structure to denature and absorb water. Lastly, I will talk about the conformational changes of edible bird's nest during processing. The processing involves three steps, which is soaking, electrostatic repulsion, and thermal denaturation. For the first step, the soaking process is also known as the hydration reaction. Occurs when the water penetrates the structure, forming the new hydrogen bonds with polar sugar groups. Move on to the next step, which is electrostatic repulsion. Since the terminal salicylic acid residues are negatively charged, as the nest hydrates in the first step, the charges will repel each other, forcing the branches to expand and creates the characteristic of swelling. Next to the last step, which is thermal denaturation. For example, heating process at the 100 degrees Celsius will break the internal hydrogen bonds, increasing the solubility of EBN, and hence There are more bioactive molecules that is absorbed by the human body. Thank you.
Diabetes Aziz A212302 and I will be your presenter for the next few slides. Edible bird nest has been treasured for centuries as its luxury food and a healthy tonic, often served during banquets and valued in traditional Chinese medicine. It's believed to treat malnutrition, boost metabolism, strengthen the immune system, and rejuvenate the skin. Its bioactive components like salicylic acid and glycoprotein also support the respiratory health, may reduce asthma, and nourish major organs such as kidney, heart, lung, and stomach. Essentially, it's a multi-purpose food that promotes overall well-being. Beyond these traditional claims, modern research shows that EBN actively supports cell growth and repair. It stimulates cell proliferation in intestinal cells, which promote gut hepatocyte and fibroblasts, supporting tissue renewal. It improves cellular metabolism like cholesterol regulation in liver cells and maintains epithelial cell integrity, offering an anti-aging potential and keeping cells healthy. When it comes to tissue regeneration, EBN strengthens the extracellular matrix through lysyl oxidase, which is cross-linking collagen and elastin to reinforce tissue structure. It enhances wound healing by protecting skin from UV damage and promoting migration and proliferation. Growth factors such as EGF, VEGF, and cytokines like IL-6 coordinate cell survival, differentiation, and communication, while acidic mammalian chitinase helps reduce oxidative stress, inflammation, and cell apoptosis. Altogether, EBN supports proper tissue formation, repair, and cellular function, linking its traditional reputation to scientifically proven benefit.
Immunomodulation, glycoproteins and salicylic acid boost immune cell activity, enhance infection resistance, and regulate inflammation via cytokines like IL-6. Metabolic regulation improves cholesterol metabolism in help G2 liver cells, nourishes kidneys, heart, lungs, and stomach, and maintains metabolic balance. Neuroprotection targets neuroinflammation, slows age-related cognitive decline, and supports cognitive health through bioactive peptide signaling. Anti-aging and skin health stimulates EGF secretion, promotes collagen production, slows cell aging, improves skin texture, and aligns with TCM beauty benefits. Respiratory support. Bioactive molecules relieve asthma symptoms, enhance respiratory health, and echo traditional uses for respiratory care.
Okay, so I'm going to talk about the physicochemical properties of edible bird's nest glycoprotein. So what is physicochemical properties? Physicochemical properties are physical and also the chemical characteristic of a compound that determines how does the compound behaves under different environmental conditions such as temperature, pH, and also the processing treatments. In the context of edible bird's nest glycoprotein, these properties are very important because they influence this protein stability, functionality, texture, and suitability for food and nutraceutical applications. So we're going to the first slide, which is firstly, I'm going to discuss about solubility and also thermal stability. Edible bird's nest glycoproteins show limited solubility at low temperatures. However, research has shown that their solubility increases significantly when heat is applied, particularly in the temperature range of approximately 40 to 100 degrees Celsius. This increase in solubility occurs because heat causes partial unfolding of the protein structure. When the structure unfolds, more hydrophobic and hydrophilic groups become exposed and allowing greater interaction with water molecules. As a result, the water holding capacity and swelling behavior of the glycoprotein also increase. In terms of thermal stability, edible bird nest glycoproteins are generally stable under moderate heating conditions. However, prolonged exposure to high temperatures can cause protein denaturation, just like the picture over here. So denaturation involves the disruption of hydrogen bonds and secondary structures such as alpha helicals and beta sheets. This structural damage can reduce the functional and biological properties of the glycoprotein, which is why excessive heating during processing should be avoided. Next, I will explain the pH sensitivity and molecular weight of edible bird's nest glycoproteins. Edible bird nest glycoproteins are generally more stable under neutral to mildly acidic conditions, typically within a pH range of around 5 to 7. Within this range, the molecular interactions such as hydrogen bonding and ionic interactions remain relatively stable. However, when the pH becomes too acidic or too alkaline, these interactions can be disrupted. Changes in pH can alter the charge distribution on the protein molecules, which may lead to structural changes, reduced solubility, and loss of functional properties. This is particularly important when formulating edible bird nest-based beverages or supplements that may contain acidic ingredients. In addition, edible bird nest glycoproteins consist of components with a wide range of molecular weights, commonly reported from tens to over 100 kilodaltons. Higher molecular weight fractions tend to contribute more to viscosity and gel formation, while lower molecular weight fragments, especially after enzymatic hydrolysis, are generally more soluble and may be more biologically active. Finally, I will talk about the viscosity and gel forming ability, which are key functional properties of edible bird's nest glycoproteins. When edible bird nest glycoproteins are dissolved in water, they form viscous solutions. This behavior is mainly due to the presence of carbohydrate chains attached to the protein backbone. These carbohydrate chains are highly effective at binding and retaining water molecules. As a result, strong protein-carbohydrate interactions are formed, creating a network that increases the thickness and consistency of the solution. This property explains the characteristic thick, smooth, and slightly gelatinous texture commonly associated with edible bird's nest product. From a food chemistry perspective, this viscosity and gel forming ability are highly desirable because they improve mouthfeel, product stability, and overall consumer acceptability. These properties make edible bird nest glycoproteins particularly suitable for use in functional foods and nutraceutical formulations. So in conclusion, the physicochemical properties of edible bird's nest glycoprotein clearly demonstrate how its chemical structure influences its behavior under different processing conditions. These properties explains its stability, texture, and functionality in food systems and supporting its value as a functional food ingredient.
Hi, my name is Mahira Atira, matrix number A210016. Here I will be presenting on applications of edible bird's nest (EBN) in functional foods. First of all, in the sector of gut health, EBN serves as a prebiotic-like ingredient. When incorporated into fermented dairy-like yogurts, it stimulates beneficial gut microbiota and provides glycoproteins essential for cellular repair. For bioactive savory foods, EBN is integrated into shelf-stable, ready-to-eat soups and porridges. From a food chemistry perspective, these formulations are designed to stabilize blood glucose and supports digestive health, making them ideal for postnatal recovery and elderly care. Finally, in ready-to-drink beverages, we see beauty drinks that combine EBN glycopeptides with antioxidants-rich juices like pomegranates. The scientific mechanism here is the stimulation of the epidermal growth factor (EGF), which is crucial for skin rejuvenation and wrinkle reduction at the cellular level. Moving on to applications of edible bird nest in nutraceuticals. EBN glycoproteins are processed into concentrated delivery systems like capsules. A major focus is neuroprotection. These supplements target neuroinflammation to mitigate age-related memory decline, specifically helping to prevent the progression of Alzheimer's and dementia. Next, in dermaceuticals, EBN functions as beauty from within. The bioactive peptide specifically stimulates collagen production and tissue repair by activating EGF pathways. Lastly, we address immune modulation. By incorporating EBN into supplements, we can enhance the body's immune response and improve immune cell activity. This increases overall resistance against infections. In conclusion, the EBN glycoprotein is a versatile bioactive agent. Its ability to interact with growth factors and immune cells makes it a cornerstone of modern functional food chemistry. To conclude this, the connection between structure and function in the edible bird's nest EBN glycoprotein represents a special meeting point of traditional nutrition and modern food chemistry. As a complex large molecule, its biological power, ranging from helping the immune system to repairing body tissues, is naturally tied to its specific amino acid makeup and its protein backbone. Understanding its physical characteristics, such as how it handles heat and how it dissolves, is very important for the food industry. This helps companies develop high-value, healthy foods and supplements that keep their natural benefits. Ultimately, bringing EBN glycoproteins into modern science proves its status as a superfood, offering great potential for future health and medical uses. That's all from me. Thank you.